Hi class. Today's video is called Radicals Video 1. This one's going to combine, in class we already talked a little bit about adding, subtracting radicals, square roots. So we're going to just do a couple review problems of that quickly and then talk about multiplication of radicals. So these notes are going to be on pages 317, 18, and 19 in your binder. So if you could pause it and take those out. We're just going to try a couple on this page here, page 317, just as review, and then take some notes on the next couple pages. So, if we start with a problem like number 7 here, all right, and it says, can you simplify the radicals so that they will be the same? So, in order to add or subtract radicals, they have to have the same number under the square root symbol. So, I have to try to simplify before I can combine. Right, and it's a good way to think of it as like terms. So if you remember, I can break down square root of 75. I could do 4 root 25 times 3 plus 3 root 3. And let's see, the root 25 is 5. So I get 4 times 5, which is 20. So I get 20 root 3 plus 3 root 3. And those are like terms. How many root 3's are there? There's 20 plus 3. So there's 23 root 3. If we do number 8, 7 root 2 plus 5 root 8. I'm going to try to get the root 8 to be a root 2. So I'd have 7 root 2 plus 5 root 4 times 2, because 8 is 4 times 2. That's 7 root 2 plus 5 times root 4. Root 4 is 2. 5 times 2 is 10 root 2. Right, and the step I'm kind of doing in my head here is 5 times 2 root 2, because the square root of 4 is 2. And then those are like terms, so I get 17 root 2. Let's do one more at the bottom of the page here. Let's see. Let's do number 11. Okay, so on 11 here, we've got 11 root 5 plus 7 root 10 minus root 45. Let's see if I can get them all to be the same here. So 11 root 5, that's already simplified because root 5 can't break down anymore. 7 root 10, the mistake people are going to make is to say, oh, it's 5 times 2. But 5 and 2 are not perfect squares, so I don't want to break 10 down that way. In fact, 4 doesn't go into 10, 9 doesn't go into 10, so there's no perfect squares that go into 10. So we just have to leave it. Now, root 45 does have a perfect square that goes into it. I can break that down into 9 times 5. So I get 11 root 5 plus 7 root 10 minus 3 root 5. And that combination, I have like terms here. 11 minus 3 would be 8 root 5 plus 7 root 10. Okay, so hopefully that's a good refresher about radicals, adding and subtracting them. Turn the page. And here on 318, we're going to start in the middle of the page, just right with our kind of example to figure out the rules here. So if we have a square root multiplication problem, like the one in the box, 6 root 2 times 4 root 14. Our first step is to multiply, and if you look at the directions here, it says multiply coefficients and multiply radicals. So I like to think of that as outside times outside, inside times inside. And maybe even a way to write that would be out times out, radical in times in. So when I do this, I get outside and outside are the 6 and 4, 6 times 4. Radical, 2 times 14. Now, you probably would not write that. You'd do that in your head. You'd get 24 rad 28. But then, step 2 is simplify the radicals if necessary. And here's where we can simplify square root of 28 to be 24 root 4 times 7. Square root of 4 is 2. So I get 24 times 2, which is 48 root 7. Okay, so it's a two-step process. Outside, outside, inside, inside, and then simplify if necessary. So let's do a few examples. Here in example 1, we've got problem A, 8 root 3 times 5 root 2. So if I do outside times outside, I get 8, where's my pen? 8 times 8, or 8 times 5 is 40. Root 3 times 2 is 6. 6 cannot be broken down into perfect squares, so I'm done. Alright, in B, I have 6 times 2 is 12 for the outsides. The inside is 12 times 4 is 48. Well, I'm going to erase that and just write 48. So 12 rad 48. And then 48 does break down. See if you can think of it. It's 16 times 3, which would be 12 times 4, which is 48. So we're going to go with 48 root 3, because this was 12 times 4 root 3. C looks a little different, but the parentheses, but there's still no adding or subtracting. So this is just a multiplication. Only multiplication. Only multiplication. When it's only multiplication, it's easy. It's outside times outside, 12. Inside times inside, root 4, 2 times 2. But then root 4 is just 2, so I get 12 times 2, which is 24. Problem D, I can write this as parenthesis times itself. 5 root 3 squared means 5 root 3 times 5 root 3. Now, another way to think of this, outside outside gives me 25. Inside inside, we've done this before. A root 3 times a root 3. Any radical times itself is just the number inside. So this is really just root 3 times root 3 is 3. 25 times 3 is 75. Another thing to kind of look for to maybe make your life a little easier is if you have perfect squares to start with. You might have noticed it in B. Here it is again in E. 5 times rad 4. Well, rad 4 is just 2. So 5 times 2, this thing is just 10 times 7 rad 18, which is 70 rad, and then 18, break that down, 9 and 2. So square root of 9 is 3. 3 times 70 is 210 rad 2, because the square root of 9 is 3. Ooh, F is important because we have a negative in there. So I'm going to do negative 6 rad 10 times itself. Again, it's only multiplication. So negative 6 times negative 6 is positive 36. Rad 10 times rad 10 is 10. 36 times 10 is 360. All right, let's flip the page. Another type of multiplying that we know how to do is distributing. So the idea is the same. We're going to distribute by multiplying to each piece that's in the parenthesis. And we're going to use the rules for multiplication that we just learned on the previous page. So outside times outside, inside times inside. Here, the thing is here, we have addition as well, okay? Oops, something just happened. Oh, it zoomed way out. Here we go. Okay, we have addition on the inside, so then we're going to have to simplify and combine any like terms. So here, the first thing I'm going to do is that root 10 times 2. Well, 10 is an inside number, 2 is an outside number, so I just get 2 root 10. Then I have plus for the distributing part, and then I have root 10 times root 5. Well, those are both inside numbers, so I can multiply them, and I get root 50. So then it says to simplify each term. Well, 10 has no perfect squares, so 2 root 10 stays. Root 50 could be root 25 times 2, so I get 2 root 10 plus 5 root 2. If I had like terms, I would combine them, but I don't, so I'm going to leave it as 2 root 10 plus 5 root 2. Okay. So let's do a few practice problems with distributing. Problem 2a here, example 2a. I'm going to distribute the 5. Notice the difference here is there's a plus sign. Okay, so unlike the previous page, these problems have addition or subtraction in them. That's how you know to do them differently. So I get 10 plus 5 times 3 root 3. My outside numbers are 5 times 3 is 15 root 3. Nothing to combine, nothing to simplify. I'm done. In problem B, 6 root 7, and then minus 6 root 10. Same thing, nothing to simplify, nothing to combine. I'm done. Let's move down. If I did problem D, I would get root 2 times root 3. Those are both inside, so I can multiply them and get root 6. And then root 2 times root 5, so minus root 10. Nothing to simplify, nothing to combine, we're done. Sooner or later we'll get something here. Problem E, root 7 times 2. I gotta do outside 2 times inside, and root 7. 2 root 7 plus root 7 times root 7 is just 7, because it's root 49, which is 7. Alright, problem F. Root 6 times root 3, that would be root 18, minus 10 root 6. Root 18, though, simplifies, and I get root 9 times 2, which is 3 root 2, minus 10 root 6. They still don't combine, though. Moving on. Let's do problem I. So when I do problem I here, notice my outside, the thing that I'm going to distribute in, is 2 root 2. So I'm going to distribute that. I'm going to get 6 root 2, because I did outsides 2 times 3, minus 2 root 2 times 4 root 6. The outsides of the 2 and the 4, which is 8, root 2 times 6 is 12. 12 can simplify, so I'm going to get 6 root 2 minus 8 root 4 times 3. So I get 6 root 2 minus 8 times 2 is 16 root 3, because square root of 4 is 2. Alright, to wrap up here, I'm actually going to have you add a problem of our own here. We'll call it problem K, since that's what comes next. Okay, problem K is going to be 2 plus rad 3 times 3 minus 2 rad 2. So this one is a double distribution problem. Okay, we know how to do this. You do the 2 times the 3, which is 6. 2 times 2 root 2, so I'm going to get minus, the outsides are 2 and 2, which is 4 root 2. And then I move on to the root 3. I'm going to distribute that. Root 3 times 3 would be plus 3 root 3. And then root 3 times 2 root 2 would be minus. I'm going to get 2 on the outside, because of that 2 there. And then my insides would be root 6. Right, so then when you look at this, you see, are there any like terms? In this case, there are not. So I'm done. All right, that is all. Thank you for watching.